So hello, everyone. Thank you for being here today. This is the first of hopefully many of these quick, short webinars that we do here, part of a series that we kind of started on best sampling practices. Previously, Nicole did one on mobile assets, and today I will be doing one on fixed assets. So in this session, we're going to dive into some essential topics that form the obviously the foundation of effective oil analysis, which is getting a representative sample and doing that with good sampling practices. So this presentation will have a focus on fixed or stationary mounted equipment, things you would commonly find in a plant or manufacturer setting, things you're probably very familiar with. This playing field of equipment, there are some considerations on sampling practices, which is, what I would like to cover for today's topic. Now, throughout the presentation, if you have any questions, please place it in the chat, and we will be happy to follow up with you during or after the presentation with the email that you are registered with. So, to start, I'm your host. I'm Sean Patrick Craig. I'm an account manager here at Fluid Life. I've been at Fluid Life for about 8 years now. Kind of have a focus in the plant manufacturer industry as well as a wind or hydro kind of power side of things. I'm also bilingual, speak English and French, so hopefully we can also do this presentation in French. Certifications, I have a bachelor's degree in criminology, and then I also have the certificate for the MLA course through Fluid Life. My email address is there if you'd like to contact me afterwards with any questions or our customer care team. So to continue with the presentation, whether you're new to the practice of oil sampling or you're looking to refine your skills of taking a sample, today's discussion will give you the practical knowledge and techniques to improve your oil sampling process for better accuracy, data accuracy of your samples. So although today's session is pretty concise, it's just 30 minutes, and it's introductory, it aims to offer still some meaningful insight on sampling and hopefully kind of get the wheels turning in your head when you see something of interest that kind of comes up in the next slide. So let's quickly walk through what we'll be covering today. So on our agenda, we'll start by looking at the objectives of lube oil sampling, why we do it, what insights we aim to gain, and how does it support equipment health monitoring, whether the component itself or the order of the oil. Then we'll dive into the best sampling practices, what a good sampling looks like, quick tips, and how consistency and that cleanliness play a critical role in the quality and the result of your data. Finally, we'll break it down, the proper sampling methods, the techniques and tools used in different systems, and how to begin selecting the right method for your application. So for lube oil objectives and goals surrounding lube oil sampling typically I'd say comprises of these 5 points. Oil analysis helps assess lubricant and equipment health. It's a simple but powerful way to monitor both the lubricant condition and the equipment health. So what does that mean? With one sample that you pull from your equipment, we can tell you if there's an issue maybe with the lubrication, it's acidifying, there's water, it's old, there's additive dropout, the viscosity is too thin or thick, or maybe all that is fine, but there's something going on with the component, excessive wear is being picked up. So that could be, maybe it's a bearing and it's off center and it's causing vibration issues. So everything could be fine with the oil itself, but the component maybe is encountering issues. So with that one sample, you can first get a good view of what's the health of my oil and component, and then maybe kind of narrow it down to one of the two. But obviously, to get that good sample, it all starts with proper sampling. So a good sample, will give you that accurate data. We're going to look into, how to do sampling easily, effectively, and efficiently for major components. That's a general objective for lube programs is, you want to do it, but how do you make it easy? And if it's easy, people will do it. Oops, sorry. I jumped ahead. So going for the third point, why would you do this? These insights can prevent failures, reduce downtime. It can improve reliability by, again, narrowing down where issues lie. If it's the health, the component, if there's some sort of a outside source that's occurring, contamination. These obviously, they can help reduce downtime, improve reliability, and which obviously kind of puts away, if you didn't have this data, to getting you to some incorrect conclusions and decisions that may cost additional time and money, where you went one way, but really it should have been the other, and that may have costed you time and money. Or instead of draining 10,000 liters of fluid, all you really needed to do was hook up a filter cart to remove the water, and esto presto, you're good to go. So saving time and money on situations. Number 4, best practice or most, it really comes down to using common sense. This is the most general guideline, and it's one that probably has the most impact on a program. Using clean tools, sampling under normal conditions, and just being consistent are very important. There are some technical factors to it, besides how you handling the sampling bottles, is using dedicated ports, sampling regularly at a scheduled interval, and avoiding contamination. These are all very important to an objective. And with the right setup and training, good sampling becomes easy and rather routine. So let's move on to the next item on our agenda, the best sampling practices. So best sampling practice, kind of just like how I highlighted there, use common sense. So when it comes to taking an oil sample, one of the most impactful things you can do for sampling is just use common sense. How to keeping that bottle clean. So start, if you're going to go take a sample, start by only removing this bottle cap here when you're going to sample. Only that cap, when you take it off, it should stay clean. Don't put it in your pocket. Don't look to set it down where it might pick up dirt, as you've seen here. And or maybe you're putting it somewhere where it's going to pick up airborne dust or debris inside the bottle because it has no cap or on the lid. Because if that happens, even just a minute amount, when you go to sample it, and let's just say there's a couple of grains of dirt, or someone's thumb accidentally rubbed the inside of the lid, when we test that sample and you get it back just that little bit amount, we're going to say, hey, your gearbox has 10 pounds of dirt in it. Well, evidently that's not true. It's just because of a simple contamination. So really be cautious, when you're taking a sample. When you're at the sampling point, before you even begin to collect a sample, use a clean rag to wipe down the sampling port or drain plug, wherever that oil is coming out of. Wipe it down so whatever crud is on that point is not going to just immediately dump into the bottle, and that's not going to be very representative. This just wiping the sampling point helps prevent external contamination from entering the bottle. Now let's just say if you're at the drain plug or valve. When you're opening the valve, don't capture the very first oil that comes out. Let some oil purge through. This clears out any sludge or non-circulated oil that may have been sitting at that sampling point. Once the oil is flowing clean, then take a sample. So a rule of thumb, if you're at a drain plug on a reservoir and you pull that drain, there's usually crud and debris sediments that are kind of sitting at the bottom of that reservoir. And as soon as you pull that plug, that's everything that's going to come out, and it's not really representative of what's circulating in the system. So you let that oil drain out, let's just say, 2-3 seconds, and then pull a sample. And same if you have a sampling port installed and it has maybe a pitot tube that's kind of sticking inside the reservoir. There's always oil sitting in that pitot tube. That's not the oil you want to sample. So even with an actual sampling point, that little tube, you want to make sure to purge that oil before you take it. Finally, after the sample is taken, allow it to cool, then, tighten the lid, retighten it. Always place the sample inside the provided shipping bag that you kind of see here. This outer container protects the sample and helps prevent accidental leaks or loss during transportation. These bags, they're also writable, so if you like to include notes in the bag, feel free to write on it. And obviously the last step, very important, identify the sample. So if you take a sample and send it to us, but you don't tell us where it's from, what it's about, that you're not going to have good data results on it because you have no idea what the results are tied to. This can obviously be done very through our FluLife MyLab web portal, so you can digitally register samples. As you can see on my picture here with the green check mark, that's a FluLife bottle with that QR code. These are unique to each jar, so when you register it, you're uniquely registering this sample to a specific component, and you can add the time if you want. Lab gets it, they scan it, and there you go. There's no question as to where it belonged to. It makes the process very, very easy. And try and use our FluLife jars, obviously. There's always other containers we receive here, and that can always introduce other contaminants into your sample. So try and use our jars if you can. They are all rated to be clean to a certain degree on the inside of the bottle to give you a good representative sample. Continuing with best sampling practices. Question is where, when, and how often. So let's look at how to determine how many samples you need and where to take them from, because both depend on what you're trying to achieve with your oil analysis program. You can see here I have a quick little chart guideline that says, if you have a hydraulic system, rule of thumb, we say, take it every 500 hours or monthly. If that seems excessive, then you can kind of roll back from it. But these are just general guidelines on things you kind of find in a plant setting. So for where, when, and how often, to answer that is start by identifying your primary goals. Like, what are you monitoring with this program? If it's for warranty's sake, go by OEM guidelines. Is it filtration performance? Is it you're trying to diagnose a failure? You're trying to identify contamination ingression. Something keeps getting in the oil and making it milky. What is it? Optimizing oil change intervals, you want to extend something. Typically, for large turbine systems with the oil that has to be in, that can go in there for a decade or 2 decades. Very common. They're trying to monitor, can they get another year out of it or a few months? So the oil replacement time takes place during a more convenient downtime instead of it being middle of summer at peak demand hours. You can set it to the fall and they say, okay, can we push it that far? That's kind of a quick goal. So you also ask yourself, what specifically do you want to monitor? Is it when you're sampling, is it the overall performance of the system, the condition of something, the pumps, are they wearing out prematurely? Are their filters getting clogged up too soon? Or maybe, it's a sample just to see what's the state of my bearings inside my system, or the babbitt wear on my very old gearbox. What do things look like? Find out why are you doing this, and that kind of helps determine when and how often should you do it. Is it a one-off? Is it kind of part of a routine program? Things like that. A key point that gets overlooked is that consistency is pretty critical when it comes to sampling. So once you determine, your sampling, location, which are important, you have to stick with it. Drawing samples from different points on the same piece of equipment can give you very different results, even though it's technically the same system. So in terms of where, try and be consistent of where you're constantly taking the sample. Try and draw a sample when the oil is hot or in service. Those are always preferable. An oil that, a system that's been shut down for the weekend or is cold, that can skew your results in a number of different ways. If there's varnish in the oil, that can plate off on the side if it's cooled off. So try and take it when the oil is hot or in service. For locations, a sample that's taken upstream of a filter might show higher particle counts than one that is downstream. So try and be consistent of where you're taking a sample from. If you're taking it from the breather or from the drain port in this picture, can kind of give you different results. But if you're constantly taking it from one, you'll have a much easier time to trending what's going on inside that system. So now quickly jumping over to proper sampling methods. So today's focus is on best sampling practices, obviously for fixed equipment, which I'm just going to say is commonly found in plant and in industrial settings. Like I said, these tend to be stationary, bolted, mounted in place, gearboxes, reducers, hydraulic units, compressors, and, and et cetera, et cetera. These things can tend to be found inside under a roof or, depending what it is, outside in the elements all the time. Nonetheless, the common thing is that they don't tend to move. They tend to be just stuck in place. So with fixed equipment in mind, we'll start by covering typical recommended sampling points and some general strategies you can apply across most systems. From there, we'll go a little deeper, look at real-world examples specifically on equipment commonly found in manufacturing environments, geared components like reducers, gearboxes, agitators, and what I call non-geared components, which is hydraulics, compressors, maybe bearing housings, pumps, things like that. We'll also touch base on the importance of sampling locations and obviously the use of dedicated sampling hardware like mini-mesh valves or T-fittings that make it easier to get clean, consistent samples without, obviously disrupting operation. So obviously the goal here is to help you apply these to the equipment you're most likely to see on the plant floor. So your oil analysis program, can be more actionable after this seminar. So I like to show you first and foremost this handy very general guideline that we have for sampling fixed equipment. The chart can be found on our website. I will provide the link in our chat. As you can see, these are great in providing a simple to understand, good, better, best scenario. While each equipment may present these locations differently and what would be possible, it does give you a good start. So, just quickly going over, if you're looking at hydraulics, a good, better, best. If you, at a minimum from the reservoir, from the, the drain port, very likely it has a breather. So, that gives you a few more options using the suction cup. And obviously the best is being able to have a mini-mesh valve to take that in sample service. So I have this slide and as well this additional slide here for some extra equipment, gearboxes, pumps. And again, these will all be on our website. I'll give you the link in the chat when I can, and feel free to use these quick guides. Now, for sampling locations, when it comes to oil analysis, where you draw the sample from is just as important as how you draw it. The sampling location has a direct impact on the accuracy and the reliability of your results. So there's some general rules or strategies we can follow to ensure we're getting a good representative sample. First, at a minimum, always try to sample from the reservoir. As we saw in the previous charts, this gives you a general view of the condition of the oil, and for the most part, you will have access to the reservoir, whether through top-ups or draining. There's not too much issue trying to access that. You can kind of see my first picture there. There's kind of it's a gearbox. There's the drain port, and as you can see, this would be an example of where you would want to maybe wipe it before taking the sample because there's tons of cement dust on there. So the second point, whenever possible, sample before the filter. This is important because the filter removes wear particles and contaminants. So exactly the things you want to know about when testing. Sampling before the filter gives you truer pictures of what's circulating in the system. So this may be contradicting to the first point because I'm saying, usually the filter is before the reservoir and things get filtered before they come back in the reservoir. However, the first point is just a minimum of what you can do. And it still would provide insight on values of the oil that might not be impacted by the filter, such as viscosity, acidity, additives, oxidation, and things of that matter. So again, sampling the reservoir is the very basic first thing to do, whether there's a filter before it or not. And third, if you can't, sampling after the pump or before the filter, but after the pump is also ideal. And one, it ensures there's pressure at the sampling point, so the oil is circulating, and it can help you detect pump wear by picking up any particles generated from the pump itself. So that kind of gives you a 2-for-1 analysis that the sample is providing insight on the pump along with the system it is lubricating. Now, it's important to note again that these are general guidelines. Sampling locations can obviously vary in how accessible these points are. In real world situations, you may get hard to reach areas, obstructions, physical obstructions, maybe a safety protocol in place that might prevent you from sampling while the equipment is running. In those cases, take what you can. You have to take it when it's shut down. You kind of do your best for it. So sampling hardware. So sampling location and hardware can depend on each other, what you can use depending on where it is. So let's go over this. So drain plug sampling, very basic, widely used method. No hardware is needed for this. As you can see in my picture, you just kind of pull the plug, let it drain a little bit, few seconds, and then take the sample. You'll commonly find this, on gearboxes and compressors, particularly older models without, built-in sampling points. Drain plug method is simple. It's not ideal for trending as it can collect settled debris or be affected by, maybe dead zones in the sump, depending on where it is. But it's, like I said, it's important to purge some of this oil that comes out before taking the sample, and let it come out a few seconds before putting that bottle to take the sample. Second common hardware is the suction pump. You would use this through some sort of access point on the system, maybe like a breather. This method uses a sample pump to draw oil through an available opening. Take out the breather or pull out the dipstick, and there you go. Now you have some sort of access. You can shove that tube down there and use the pump to suck that oil up and get it into the jar itself. The last one, mini mess valve assemblies. These are, you can kind of see it here on the top picture there. With the little pitot tip. So these are kind of considered the best practice for clean, repeatable sampling. You could do it on pressurized or non-pressurized system. Very commonly used in hydraulic systems, and depending on the application, the equipment, you have different locations where you can install these mini mess valves, this hardware, this sampling hardware. And obviously it makes it much easier to do if you have a dedicated sampling point. So just to kind of look over some pictures quickly, let's take a look at the hardware offering. Suction pump, low and high pressure sampling valve. So quick sampling tip on suction pumps. Obviously, these can be susceptible to contamination. You got the hose, you got to attach the jar on, you got to put the hose in the pump, and then, then you got to take the breather hole off. So you're still introducing points where contamination can happen. For sampling pumps, it's always suggested for that hose, use a new one every time, because if you say, hey, I'm using my hose on this gearbox, okay, now I'm going to go to my hydraulic system and stick it down the reservoir, the hydraulic tank. Well, that tube has, gearbox oil in it, and now your result on that sample is going to be a bit screwy. So use new tubing when you can, and be mindful when you're pulling a sample. Don't overfill this jar because it can mess up the pump as well. The oil will kind of get into the inlet here and mess up your pump. Now we have, low and high pressure sampling points. Obviously, these are commonly installed on, return lines, low pressure zones. These make it very easy to take samples. You can kind of, if it's push button, you can straight up go up to and press a button, take a sample, and it allows you to take a sample when the system is live or hot, which is extremely preferable. So to be able to have that option is great. And it makes it so in terms of meeting a schedule, taking a sample this day or that day, makes it more likely you don't have to wait on maybe specific downtime. It, again, makes it clean, repeatable, and just easy to do using sampling hardware. Now, depending on the sampling hardware, on the units, sometimes you have to kind of get an audit to find out where you can install them. If it's newer equipment, they tend to have kind of ports ready to install these things. If it's older equipment, sometimes you need to, tap and die. I don't really suggest that, or you kind of have to retrofit it in some other way, maybe off a sampling gauge, teeing off from something else, maybe a site class. You can use that and get the sampling hardware attached and fixed in that way. So now that we've kind of covered the importance of sampling location method, let's kind of shift our attention here to different types of equipment, like I promised, in the kind of fixed equipment setting. So in the next few slides, we're going to take a closer look at three key categories, each with their own kind of sampling considerations. So we'll start with the gearboxes and other non-pressured units. These are obviously very common. You guys see them all the time. We'll move on to hydraulic systems and pressurized equipment. And finally, we'll look into compressors, which can be a bit of a unique case because of the temperatures in the gas and whatnot. So for gearboxes, straight up, simplest way to do it, drain plug. most basic and widely used method, draining directly from the drain port at the bottom. I think every gearbox has this. Same with compressors. Older models may not have that built-in sampling point, so that's maybe all you have. But however, newer equipment will have those pre-threaded ports or plug locations where you can kind of install these things. While drain plug sampling is simple, it's not ideal for trending. It can collect debris and whatnot. It also, gearboxes using the suction pump is also kind of a common thing to do through the breather. So obviously this method, you can either take off the breather at the top, put the tube down, or maybe there's a dedicated sampling point. Maybe this used to be a dipstick or something like that, and now they've retrofitted a sight glass on it, so they're reusing this dipstick hole as kind of a sampling point. Like, that is the sampling hardware. You attach the pump onto that. Obviously, it's a gearbox, there's no pressure, so you need the pump to pull up that sample, but it allows you to kind of pull a in-service live sample. But for the most part, for gearboxes, I see a lot of it's sampled offline unless you have this special equipment installed. So kind of a gearbox with the best-in-class sampling hardware equipment. Here's one you see here. So obviously this one, it had a breather, which now they've kind of had a filter on, but now they teed it off that this desiccant filter also has a special line that if you wanted to filter this oil while it's in service, you can bring a filter cart, filter the gearbox oil. This thing at the bottom, you can see, also has a sight glass. There's also the return line. At the top there's a return line. There's the feed line for if you want to filter it. There's the little sampling point at the bottom. So this is kind of, for a gearbox, best in class. You can filter that oil without draining it. You can pull a sample while it's still on. You can monitor the oil levels inside the inside the reservoir best you can. Again, this is kind of best in class. And like I mentioned, this may not work in your situation because of obstructions or where the gearbox is. And that's why every case is not necessarily the same. But what is kind of consistent is at site, if you guys have the same make model gearbox, what works on one will likely work on another, in terms of what hardware to kind of purchase and buy to make this go a little bit easier. So for hydraulic systems, so, this is a very generic view of a hydraulic system. Hydraulic systems are nice because when they're live, they provide good pressure and good flow, which is great for the sample because you can take a nice representative sample. The ideal location on hydraulic system is the return line before the filter. So here's that return line filter. So maybe where this little P point is, that could be a sampling point while the system is under normal conditions. This will kind of give you a good idea of the health of, if the health of the cylinder, the valve block, whatever it may be, because this the return line before the filter is the oil after it's kind of gone through its workload, its process of lubing system, and now it's going back to the reservoir. So if there was anywhere debris, you'd be capturing it right there. A neat thing on kind of these filters, you may notice on the filter housing, there's kind of a plug on it. Sometimes you'll see that on the bottom or at the top or the side. And those plugs may be very easy, quick and easy sampling points if they are before that oil circulates through the oil, which from what I've seen many times is. So if you're looking around, you're like, hey, I don't want to tee off from here. I don't want to rip a line here just to add a sampling point. You know what? Look at your filter housing. I bet you there's something on there, a threaded port that offers you some sort of solution before that oil will get sampled. And if the system's on, you got pressure, that kind of makes sampling a little easier for you. Another good option is obviously downstream. Try and, when you're sampling on here, avoid, like I said, filters or stagnant lines like bypass lines. Obviously, you don't want to add a filter. You don't want to add a sampling point on something like that. Always think about, accessibility, how easy it is to get to some of these sampling points. If this is a very large system, maybe add multiple sample points. Maybe add one after the pump, after the valve block. So if there's an issue, you don't just have a sample that says there's an issue on one of your 5 pumps. If you have a sampling point after each pump, you could really narrow it down, and obviously that saves time if you can tell exactly which one is causing problems. Here's another one, just a live picture of like a general loop system. So if you wanted to add multiple sample points, most basic, put it on the reservoir, right? But look, if you said, hey, I want to know if I have pump problems, add a sampling point right after the pump, before the filter, on the return line, wherever it may be. If you wanted to kind of get a much, greater view of how things are going on, how to trend and monitor specific components on a loop system, which is very common for hydraulic systems. They tend to be kind of a big connected piece depending on your operation with multiple points along the line. And a very common thing with the hydraulic system is, things you want to avoid is varnish. And varnish is a tricky beast where it can appear in one spot and not another, because where it's circulating, it might plate off and attack one specific component, and then down the line, it doesn't exist. After a pump, there's cavitation, so it's affecting a lot one cylinder and not the other. So big hydraulic systems, very advisable to try and put multiple sampling points on it. Lastly, compressors. So compressors commonly found and used, for rare reasons on site. If it's it could be a mobile shop where they're fixing the big mining trucks and they need a compressor for the air tools, or maybe the plant is it's an ammonia-based compressor or a nat gas compressor at some sort of biogas facility. But nonetheless, they all kind of special case when it comes to oil sampling. These things, they tend to be dealing with high temperatures, usually, some sort of gas contamination, intrusion, that oil is kind of forcing itself with air or whatever it is to compress it. And they tend to sometimes have limited safe access points. In those cases, these things are enclosed. So having a kind of nice sampling procedure points and making it consistent is kind of viable, not just using a drain plug, but maybe using some sampling hardware. Now, a lot of these, especially because, again, newer models, maybe past 15 years, you'll start seeing dedicated points where you can install it, or it already exists. So in this case, there's one at the bottom here where it allows you to kind of pull a system from the reservoir. The second picture in the middle there, it looks like it's a mini mess valve. You kind of press it, and that looks like it's probably after the pump, before the filter, where you can kind of pull it in, sort of sample on this big compressor guy here. And the one on the far right, obviously it's a little smaller, so you don't have too many options here. Obviously there's the fill port. That depending on what it is, you could tack on something on here to add a inline sort of sample. Probably something on the far right there. So again, in these cases, depending what it is, maybe shutting it down is the only practical options. But for compressors, it is advisable to try and get some sort of sampling method onto it, hardware, because they tend to be usually always critical. You can't really have them down, and there's not always a shutdown time on them. They tend to always need to be kind of in a steady state, and there's not usually kind of backups for it on site. So I know, like for gearboxes, sometimes they will always have kind of an inventory stash of a few of them ready to go, spare parts or whatever it may be, but compressors can be a little bit tricky. So again, it's the same thing when it comes to sampling compressors. Try and avoid, dead ends on it. Try and avoid sampling when this thing is shut down or cold, because how the oil works and how it's being used in the compressor could kind of skew some of your results. So again, same with compressors. Picking the right sampling point is key to kind of getting those reliable results. And really, best sampling practice on these is try and use a dedicated sampling point if you can, or have one, installed. So, I think kind of went through that there. So to wrap it up, when monitoring, fixed gearboxes, pardon guys, it keeps jumping away from my one slide. So kind of when monitoring these systems, sampling at regular intervals using steady state is kind of the best way. Sampling when it's hot and warm, that's usually the most advantageous thing you could do for your program to kind of get a good view of things. When it comes to very common gearbox, hydraulic systems, compressors, whatever it may be, the best sampling practice for those is, again, at a minimum, take it from the reservoir, take it when the oil's warm, but best way is usually when the system is running, and that is using sampling hardware, mini MES valves. And not every case is going to be the same. So the hardware exists to kind of tackle most situations, but if it's something you're interested in, you would like to do, feel free to reach out to us. We can assist you in kind of obtaining that hardware, getting it, taking some pictures of the unit and saying, what should I do here? Sending that over to us, and we can kind of assist you, for that. So, I hope that this session has kind of helped reinforce just how, critical, proper oil sampling is, to, the success of your program. Kind of, have we seen reliable data starts with a clean, consistent sample, a good representative sample, because if it isn't, it's not going to give you some true value as to what's going on. Now, with what you see here, whether you're trying to implement new processes or refining existing ones, even small improvements can lead to much better insights, fewer surprises and more informed maintenance decisions. So just the fact of, maybe taking multiple samples along a big point versus just one you might suddenly see a big difference in results just from that. But obviously, I would also kind of, if you have any further questions, on sampling training or sampling hardware, please reach out to our customer care team or leave a note in our chat here. We'd be happy to continue the conversation. I would also like to point out a promotional offer we have for our MLA MLT certification course. That will be happening in our headquarters in Edmonton, Alberta, and as well as our lab in Irving, Texas. I think both are going to be in November. This information, all of it can be reserved, can be found on our website. So that promo code, it just kind of helps you save some money on the registration or the certification for the exam part after the fact. So, thanks again. I wish you all success in applying some of these practices for your own operation, or maybe kind of assessing where things might matter for you. And all the best. Again, any questions, please feel free to just write them in the chat, and we will follow up with you with that email that you registered with.